This time, let's have operations on integers. But before we proceed, let's go back to the definition of integers. Again, integers are a set of numbers consisting of whole numbers and their negatives. On the number line, from 0 going to the left is the set of negative numbers. From 0 going to the right is the set of positive numbers. 0 is not positive nor negative. So let's have the first operation on integers, which is addition. In adding integers, we have three methods. The first one is by using the number line. For example, positive 3 plus positive 4. On the number line, positive 3 is located 3 units to the right of 0. So let's plot positive 3. Always remember, if you're going to add positive numbers, the movement will be to the right. If you're going to add a negative number, the movement should be to the left. So again, let's go back to the example. From positive 3, since we are adding positive 4, we're going to move 4 units to the right of positive 3. So 1, 2, 3, 4. Meaning to say, positive 3 plus positive 4 is equal to positive 7. Another example, negative 2 plus negative 7. Again, on the number line, since 2 is negative, it is located 2 units to the left of 0. And since we are adding a negative integer, we're going to move to the left. So from negative 2, let's move 7 units. Again, to the left. 1, 2, 3, 4, 5, 6, 7. It ended up on negative 9, meaning to say, negative 2 plus negative 7 is negative 9. Let's have another example. Negative 4 plus positive 9. Negative 4 is located 4 units to the left of 0. We are adding a positive number, so our movement will be to what direction? Correct, we're going to move to the right. So from negative 4, 9 units to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is 5. Therefore, the sum of negative 4 and positive 9 is positive 5. Another one, 6 plus negative 10. So we have positive 6. As you can see, 6 is 6 units to the right of 0. And we are adding negative 10. So from positive 6, we're going to move 10 units to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it is negative 4. Therefore, positive 6 plus negative 10 is equal to negative 4. So that's how we add integers using number line. So let's proceed in the other method of adding integers, and this is by using algebra tiles. So when we use algebra tiles, we are having two different sets of colors. The first color will represent the positive integer, and then the second one will represent the negative integers. So let's use the colors that we have on our number line a while ago. So the blue tiles will represent positive integers, while the red ones will represent the negative integer. For example, again, we have positive 3 plus positive 4. Since we have positive 3, we are going to have 3 blue tiles. 1, 2, 3. And then we're going to add positive integer again, which means we're going to add blue tiles again. So, 4 blue tiles. 1, 2, 3, 4. All in all, we have 7 blue tiles, which means positive 3 plus positive 4 is equal to positive 7. Another example is negative 5 plus negative 6. This time, we're going to have red tiles because the first addend is negative 5. So 1, 2, 3, 4, 5. And then we're going to add more red tiles because we need to add negative 6. So 1, 2, 3, 4, 5, 6. So all in all, we have 11 red tiles. Therefore, negative 5 plus negative 6 is equal to negative 11. Let's try this. Positive 9 plus negative 3. So positive 9, meaning to say we're going to have 9 blue tiles. And then negative 3, it will be represented by 3 red tiles, but we cannot continue it here. They have different colors, so we're going to put the 3 red tiles below. And as you can notice, we have pairs of blue and red tiles. These pairs are what we call zero pairs. Remember our lessons on concepts of opposites? Additive inverses or the opposite numbers have the sum which is always equal to 0. So if it is 0, if these 3 pairs are 0, these are not significant anymore. So what are left are 6 blue tiles. Therefore, the sum of 9 and negative 3 is equal to positive 6. Next, negative 8 plus 5. Negative 8. So we're going to have 8 red tiles. And then we have positive 5. Again, eliminate those 0 pairs. What are left are 3 red tiles. So, the sum of negative 8 and positive 5 is equal to negative 3. So, let's have more examples. Imagine that you have there your algebra tiles and number line. So, let's get the sum of the following. 5 plus 4 is equal to, very good, it's positive 9. How about 2 plus positive 10? Correct, it is 12. Next, negative 5 plus negative 4. Yes, it is negative 9. How about negative 2 plus negative 10? You're right, it is negative 12. You can notice that the addends on the first set are both positive, while on the second set, they are both negative. So these are what we call like signs. And to add integers with like signs, you add their absolute values, then copy the common sign. How about the next examples? 5 plus negative 4. Yes, it is positive 1. Negative 2 plus 10. Correct, it's 8. How about negative 5 plus positive 4? Very good, it is negative 1. Next, positive 2 plus negative 10. You're correct. It is negative 8. Now look at the new set of examples. As you can notice, the addends have different signs. One is positive, the other is negative, and they are called unlike signs. To add integers with unlike signs, you subtract their absolute values, then copy the sign of the integer with the greater absolute value. In adding integers, we can apply this song for you to add integers easily. If both signs are positive, add them up. If both signs are positive, add them up. If both signs are positive, then the sum is positive. If both signs are positive, add them up. If both signs are negative, add them up. If both signs are negative, add them up. If both signs are negative, then the sum is negative. If both signs are negative, add them up. If the signs are different, you must subtract. If the signs are different, you must subtract. You look at the greater value, the sum will be the sign. If the signs are different, you must subtract. Okay, let's have the second operation, which is subtraction of integers. In subtraction of integers, we are following the rules in adding integers. So if A and B are both integers, then A minus B, A represents the minuend, and B represents your subtrahend. So it is, or it will become A plus negative B. So in subtraction of integers, I have this method which is KCC. What is that KCC? You keep the minuend, you change the operation to addition, and you change the sign of your subtrahend. Again, KCC. Let's say for example, we have 7 minus 3. So let's keep 7, change this into plus sign, change the sign of 3, and it will become 7 plus negative 3. Follow the rules in adding. So, different sign, subtract, copy the sign of the number with the greater absolute value. So, 7 minus 3 is equal to 4. 7 is positive, so the result is positive 4. Next, 3 minus 7. Keep, change, change. So, it will become 3 plus negative 7. And again, they have different signs, so you subtract. 7 minus 3 is equal to 4. Negative 7 has the greater absolute value. Therefore, the answer is negative 4. Next, negative 7 minus positive 3. Keep negative 7. Change the operation, you change the sign of your subtrahend. So, it will become negative 7 plus negative 3. Adding the same sign, so you have to add the numbers, copy their common sign which is negative. The sum is negative 10. Plus 3 minus negative 7. So doing the KCC, we're going to have this. Keep positive 3, change the operation, you change the sign of negative 7, it will become positive 7. So add the numbers, keep the common sign which is positive, the sum is positive 10. So let's proceed with the last two operations, which are multiplication and division of integers. We have the same rules in multiplying and dividing integers. The first rule states that in multiplying or dividing two integers having the same signs, the product or the quotient is always positive. Example, positive 3 times positive 4 is equal to positive 12. negative 5 times negative 7 is equal to positive 35. So in the first example, they are both positive, so the answer is 12. Second example, they are both negative, therefore the product is positive. Next, 4 times 6. They are both positive, right? So the answer is positive 24. How about this one? The dividend and the divisor have the same signs. They are both negative. So meaning to say our quotient will be positive. And 18 divided by 9 is 2. So the answer here is positive 2. The second rule states that in multiplying or dividing two integers having different signs, the product or the quotient is always negative. Example, negative 8 times positive 6. They have unlike signs, meaning to say the product will be negative. And 8 times 6 is equal to 48. Therefore, the answer is negative 48. How about 10 times negative 3? Again, they have unlike signs. Therefore, the answer is negative. Negative 30. Next, 42 divided by negative 6. So you know that the quotient here is negative because they have unlike signs. 42 divided by 6 is 7. So the quotient here is negative 7. And finally, negative 54 divided by 9 will result to negative 6. We have also a song for multiplying and dividing integers. It goes like this. Multiplying and dividing of the same signs, you will get a positive, now you know, multiplying and dividing of unlike signs, you will get a negative, now you know. Let's see if you have learned something today. Perform the indicated operation in each given. First, positive 7 plus negative 5. What's your answer? If it is positive 2, you're correct. Negative 8 plus 17. Very good. It is positive 9. How about this one? Positive 14 minus 25. Correct. It is negative 11. Positive 9 times negative 7. Very good. It is negative 63. Negative 15 times negative 4. Good job. It is positive 60. And negative 63 divided by positive 9. Very good. It is negative 7. You did great today.